So we're doing central and inscribed angles today. The only two types of angles that are listed on your vocab sheet. You don't need to write down the definition because it's already on your vocab sheet, but you can write down the theorem. You can write down the connection. So I would draw the picture in your notes, and I would write the formula. Notice how it says the measure of the central angle is equal to the measure of its intercepted arc. So I'm using certain vocab, and we're going to talk about what that means. So, why is ABC a central angle? Why? It's all about the vertex. Where is the vertex, always the middle letter, where is the vertex of that angle? It is the center. On the center is the center. So this circle is called circle B because B is the center. And when the vertex is the center, then we have a central angle. What are the rays of a central angle? What's the vocab word for the segments that make up the central angle? Good. Radius. So this always made up of the radii intersecting at the center. Okay, so what this formula is saying is that the measure of this angle is equal to the measure of the arc that it opens up to. And we're going to call that an intercepted arc. It's equal to the measure of the arc it opens up to. So if I said that this arc had a measure of 50 degrees, then the angle would have a measure of 50 degrees. So this theorem is about as easy as it gets. The measure of the central angle simply equals the arc that it opens up to. Because what's going on here is a long time ago, the Babylonians decided that there were 360 degrees in a circle. So if I were to start here and travel full circle, I would travel 360 degrees. Likewise, if I were to start here and travel full circle, I would travel 360 degrees. So those are going to be the same portion of 360. That angle and that arc will be the same portion of 360. Okay. The next one that we're going to talk about is how do you find the measure of an inscribed angle? You don't need to write the vocab down because that is already on your vocab sheet, so don't take time to do that. Reminder that an inscribed angle has a vertex that lies where? Good. On the circle. On the circle. So the inscribed angle has a vertex that lies on the circle. So we call ABC with an angle symbol. Pretend like I use an actual angle symbol. Angle ABC is called the inscribed angle. And arc AC, minor arc there because 2 letters, AC is called the intercepted arc. Sometimes I like to think of it as like Pac-Man. Like, what arc is it going to eat if it is hungry? It's going to eat arc AC. That's its intercepted arc. So now we're going to find out how those are related because they're not equal this time, right? They're not going to be equal this time. Now you're hungry. Have you ever shot a bow and arrow, whether it was plastic or real? So when you shoot a bow and arrow, the initial position of the bow is that the string is like a straight line, 180 degrees, right? Now, as you start to shoot the arrow, you pull the string of the bow back, and what happens to that angle that used to be straight up and down? What happens to the angle as you get further and further away? Yeah, it gets smaller and smaller and smaller. So I want you to think of this, I don't know if you can see me looking at the board, as you get further and further away from the center, the angle gets smaller and smaller. But how much smaller does it get? Let's use our 50 degrees again. Let's say this is 50, meaning the central angle is 50. I know the inscribed angle is going to be smaller than 50, but how much smaller is it going to be? So let's see. So here, this arc is the exact measure of the inscribed angle, and we're going to compare that measure to the measure of the central angle. So I'm going to bring this over here. I'm going to rotate it because 1 is not going to cut it. I'm going to obviously need more than 1. Do you have a hypothesis? Probably. I'm going to show you that this equals exactly the inscribed angle. Then I can move it over here. Let's give them the same vertex. Rotate it a wee bit. There we go. I promise it's perfect. Okay, so the inscribed angle is exactly, you said it, 1/2 of its intercepted arc. So what's the measure of the inscribed angle? So it's half of the central angle and it's half of the intercepted arc. Let's write that down in our notes. Oh, let's skip it. Okay. If I were you, I would draw the picture and I would write the formula, but I don't think you need to write the words because the formula takes care of that. So draw an inscribed angle. We're not being original here. We're calling it ABC again. The measure of angle ABC is 1/2 times the measure of the intercepted arc. This works every time that the angle is an inscribed angle. So, I'll make up a new number. Let's do 74. If the arc measures 74 degrees, then the measure of the inscribed angle would be half of 74. Yeah. Now, what it would not work for, and we'll learn about this after spring break, it would not work for this angle, because that angle is neither central nor inscribed. So we're going to have a new theorem for the purple angle. We do not know how to solve for the purple angle yet. So we've only learned central and inscribed. Vertex on the center, vertex on the circle. All right, we are given the measure of angle. You have to, in this unit, you have to really pay attention to notation. Given the measure of the angle, not the arc, angle ABC. So we know it is 152 degrees. We need to solve for the measure of arc AC. First of all, minor or major arc? Minor arc. Now, when we say minor arc, what does that mean? What are the range of values that a minor arc could equal? Yeah, so a minor arc needs to be greater than 0 and less than 180. But it could be 0.5. You know what I mean? Okay, so anyways, yes, the measure of arc AC is 152 because we learned that a central angle measure is congruent to its intercepted arc. All right, the measure of angle symbol, ABC. Vocab word for angle ABC, vocab word. Thank you. Inscribed angle. We just learned that an inscribed angle measures 1/2 of its intercepted arc. So go ahead and type the answer, 1/2 of 152. Good. And lastly, what do you know about the measure of arc ABC? Not angle, but arc. Yep, you know it's a major arc. You know your answer better be greater than 180. You can go ahead and type that in. What is the measure of arc ABC? Very good. 208, and you got that number by doing what? Subtracting 152 from 360. Very good. Let's move on. We're going to try this example. I'm going to label it, and then I'll give you time to draw it in your notes. ACD is 62 degrees. Arc CD is 58. And arc BC is 47. Okay, let's see what we can find. The measure of angle ABD. Oh, no. We learned that the measure of inscribed angle is 1/2 of its intercepted arc, but we don't know the measure of the intercepted arc. Who has an idea? So we don't know the measure of arc AD. Could we find the measure of arc AD? You got it, Toby. You're right. So I know that my angle that I'm looking for is opening up to this arc. Do you see another angle that's also opening up to arc AD, intercepting arc AD? What's the opposite of halving something? Doubling it. Yep. So to get the inscribed angle, you half the arc. To get the arc, you double the angle. That arc has a measure of 124 degrees. And now to get angle ABD, we're going to undo what we just did. 124 inscribed angle divided by 2. Did we have to find arc AD in order to find angle ABD? We could write our own theorem right now, couldn't we? We could say if two angles intercept the same arc, then they are, oh, I'm sorry, it's 62, you're right. If two angles intercept the same arc, then they are congruent. So congruent angles are going to intercept the same arc. As long as they're both inscribed angles, you can't compare an inscribed to a central and vice versa. Okay, next one, arc ADC. Now I want to be careful here. The way to locate that arc is to start at A, to travel through D and to end at C. So start at A, travel through D and end at C. Sometimes people accidentally go the other way around. That wouldn't be arc ADC, it'd be arc ABC, so be careful. 3 letters, major arc. The answer has to be greater than 180. You got it? All you do is add them. You get 182, just barely squeezing by as a major arc, right? Yes, Alex, I said that in the vocab video. Yes. Last one. Measure of angle BDA. Vocab word. Angle BDA is an, giving you a hint, starts with a vowel, inscribed angle. Inscribed angles are half of their intercepted arc. Kind of looks like an ice cream cone when you put it all together. We need to find the measure of that arc so that we can half it and find the measure of our missing angle. Yep, add 124, 58, and 47. Subtract it from 360. Very good. What is the measure of arc AB? Good. 131. It is not a central angle, it's an inscribed angle. So we take that and we divide by 2, and we get a decimal, and we don't freak out about the fact that it's a decimal. Decimals are angles too. Okay, let's try this example. Oh my goodness, there's no numbers. Try this example. So when a chord goes through the center of a circle, it receives a promotion. What is its new title? Diameter. Okay, good. When a semicircle begins and ends at the end points of a diameter, oh, I answered my own question, JK. When an arc begins and ends at the end points of the diameter, it is called a semicircle. And how many degrees are in a semicircle? Always 1/2 of a circle. So there are 180 degrees from here to here. So you know the equation? What's the equation? Yep. Part plus part equals whole. Arc addition. 3y equals 180. Y equals 60. And if this arc is 60, then that inscribed angle is 30. Very nice. What do all of these pictures have in common? I want you to just stare at them and come up with some commonalities. There's a triangle in all the pictures. Yep. Every circle in the universe is similar, actually. That's an all. All circles are similar. They're all inscribed angles. What's true? Good. What's true about AC in every picture? AC is the diameter in every picture. Okay. Angle ABC in every picture is what kind of angle? An inscribed angle, but Jessalyn already knows the answer. So, what is the arc? What is arc AC in every picture? Arc, the measure of arc AC in every picture. Right? Because AC is a diameter. Now, if an inscribed angle is opening up to that same arc every time, what is the measure of angle B in every picture? Every picture, what's the measure of angle B? Inscribed angles, half the arc. So in this picture, it's 90. In this picture, it's 90. And in this picture, it's 90. So what I want you to understand is that if an inscribed angle is opening up to the diameter, then it is a right angle. And I don't care how close B gets to A. If I had Sketchpad out, it would let me take this and it would let me drag the angle all over. But what I'm saying is I don't care where B is located. B can be located anywhere along this arc, and angle ABC will be a right angle. So here's the theorem that you can write down. So an angle inscribed in a semicircle is a right angle. Another way to say that is an angle, an inscribed angle that opens up to the diameter is a right angle every time. You forget this theorem and you're going to be just fine. Because if you forget the theorem, you'll write down the degree of the arc and then you'll divide by 2 and you'll get 90. So it's not a theorem that you have to memorize. You just understand why it's a theorem. It works every time. Next picture. Use some vocab words and tell me what you see in this picture. In our last page, we had an inscribed angle. Let's look at this picture a little bit more. ABCD is an inscribed quadrilateral. It has 4 sides and every vertex is on the circle. How is angle A related to angle C? Use a describing word. Opposite. Yeah, they're both inscribed angles, but how are they related to each other? A and C are opposite angles. Okay. What can you conclude about the measure of angle A plus the measure of angle C? Well, let's stop right there for a minute. Okay, they're both inscribed angles. So, angle A is going to be half of this arc right here, of arc BD. Angle C is going to be half of this arc right here, of arc bad. So angle C is going to be half of the red, angle A is going to be half of the green. What do you get when you add the red and the green up? 360. So I don't know angle A, and I don't know angle C, but what will they add up to? They're inscribed angles. Half of 360, very good. I don't know angle A, and I don't know angle C, but I do know whatever they are, in cooperation, they're going to add up to 180, because they are half of 360, they're inscribed angles. Yep. Didn't you already know that opposite angles are supplementary? No, that's new. That's weird. In the quad unit, opposite angles were congruent. So what can you conclude about opposite angles of an inscribed quadrilateral? They're supplementary, which is weird. It kind of goes against what you're used to in the quad unit. We'll talk a little bit more about that when you write this theorem down. So you wrote down that the opposite angles of a quadrilateral inscribed in a circle are supplementary. So how does that play out with what we just learned? In the quad unit, we learned parallelogram, opposite angles are congruent. And now I'm telling you opposite angles are supplementary. Do those clash? Do those negate each other? So, if opposite angles are congruent and opposite angles are supplementary, can you inscribe a parallelogram into a circle? Could they go together? Could you be both of those at the same time? 2 times. Which ones? Yes, if it's an or a rectangle or square. Those are the 2 times when the opposite angles are both congruent and supplementary. Could you put just a plain old, forgive my not perfect circle, could you put a plain old parallelogram, trying to make it parallel, could I put a plain old parallelogram into a circle? I couldn't, unless the opposite angles were 90. I just couldn't do it. It wouldn't fit. The only way I could make this parallel to this, when I finally connected them to force it to stay in the circle, then I would have no choice but them to be 90, 99. Anyways, we're going to do one more example. If you need to log out, you can. Oh, we're not going to do that. Okay. The parallelogram is making me uncomfortable. Okay, DF is tangent to circle O. When I went over the vocab, I did say that a tangent is always perpendicular to the radius at the point of tangency. So we're going to learn that theorem a lot better in 2 weeks after spring break. But I'm going to go ahead and add that to the picture. Find the measure of DOF, so that's pretty easy, using triangle sum theorem there. Find the measure of arc BC. Find the measure of arc DE. Find the measure of arc DBA. All right, so find the measure of DOF. What'd y'all get? 90 minus 33. 57. Okay, what kind of angle is DOF? Vocab word. Central angle, very good. Central angles are equal, their measure is equal to their intercepted arc. So now I know arc DE, the measure is also 57. What about arc BC? Well, let's label some more arcs. Let's use what we know about central angles. 80, 80, 90, 90. Now I can use the fact that circles have 360 degrees to find arc BC. This one yet. 23. Adding up the angles and subtracting from 360, a nice little minor arc. And the measure of arc DBA. This is really just testing, do you know which way to go? Do you know which one is arc DBA? Because I know everyone can add numbers together. So just make sure you start at D, you travel through B, and you end at A. So add those up. The sum is 193 degrees. On your homework, the front is homework that's about the vocab, and the back is homework about the central and inscribed angles. So don't just do the front and put it away. Don't just do the back and put it away. Make sure you do all of it, or you do a little section of each. Okay?